finally, let's define the derivatives. So the derivatives of a function f at number a, and that's the notation, f prime of a. So that's how we define f prime of a, which is the limit. So make sure you memorize the definition, and remember earlier we have two expressions for the limit. One as h approaches 0, the other one x approaches to a. So either way is good. So let's take a look at the example. So we have f of x equals to x squared minus ax plus 9 at the number a. All right, so from the definition, I'm going to find the derivative. Let's use, because we have the number a, so let's use the expression. Let's use the expression limit h goes to 0. So f of a is the limit at h goes to 0, f of a plus h minus f of a over h. This expression is better than the other expressions. So from time to time, you will see that we use this expression more often than the other. All right, let's plug it in. So what we have for our function, f of a plus h, which is what? So I have x squared, so that's going to be a plus h squared minus 8 times a plus h plus 9. And we have to do the same thing for f of a, which is a squared minus 8a plus 9. You will see that we have to do a lot of cancellation. So let's FOIL. A squared plus 2ah plus h squared minus 8a minus 8h plus 9 minus a squared plus 8a minus 9. Hopefully I didn't make any mistake. All right, let's cancel something else. So that, go with that, this one with this one, this one with this one. So we ended up with the limit h approaches 0. We have 2ah plus h squared minus 8h divided by h. Okay, so the whole point is we want to cancel out the h. So we ended up with limit h goes to 0, 2a plus h minus 8. And then don't forget, we get to put h in. So h is 0, so we ended up with 2a minus 8. And that's the derivative. So this is what we call f prime of a. Okay, so we have to define the tangent line. So the tangent line at the point to be the line that passes through P and has a slope of m. And now we know the slope is the derivative. The slope of the tangent line is the derivative, which is the limit. So if we use the point slope form of the equation, this one, okay, y2 minus y1 equals to m times x2, y minus x1 equals to m times x minus x1. So hopefully you still remember that formula, the point slope form, which is this one right here. All right, so moving on to the next example, you see right here, that's our example 4. So that's the function we have for example 4, x squared minus ax plus 9. Now I have the point. So they're asking you to find the equation of the tangent line. Recall, from example 4, we know the derivative at the number a is f prime of a is 2a minus 8. So the slope of the tangent line, the slope of the tangent line at 3, negative 6 is f prime, and what's a? A in this case is 3. So you just have to plug it in. 2 times 3 minus 8, which is negative 2. Okay, so now using the equation, we have y minus negative 6. The slope is negative 2, x minus 3. And you simplify it, you ended up with y equals to negative 2x. And this is our tangent line.